Welcome, everybody. Welcome to this talk on modernizing your data with Postgres and MySQL flexible server. My name is Sunil Agarwal. I'm a PM manager for Postgres team, and with me I have Parikshit, who drives the MySQL and MariaDB team. So in this talk, we will focus on why flexible server. As you know, today you can run Postgres and MySQL on single server. So why we introducing a flexible server? And then we will walk through the flexible server offerings, the key details, and then finally choosing the right deployment option for deploying your workload. Okay, so if you go to the Azure portal today and you choose to configure, let's say, Postgres or MySQL, you will see a single server option. And this single server option is for both Postgres and MySQL, and it offers you enterprise-ready, fully managed community Postgres server, also MySQL server, and you can sort of host it up to 64 vCores, and it has host of capabilities that come with Postgres, with like a full geospatial data, full text search, and more. And then if you look after that, there is a offering called Hyperscale Citus. This is an acquisition that Microsoft did in year 2019. And this hyperscale went in GA November of last year, 2019. And it offers you a scale out model for Postgres. It's multi-tenant scale out model, and it is suited for high transactional workload as well as a real-time analytics HTAP scenario. The focus of this talk is not hyperscale Citus, so we will skip that. In parallel, we also introduced a Arc-enabled hyperscale. What Arc-enabled means is you can deploy your hyperscale Citus on-premise, or you can specify on edge devices, or you can even deploy on other public clouds like AWS. And again, there is a talk which will go more detail into Arc, so we will not go further into it. And then the topic of today is the flexible server. So single server, we are offering a very comparable, but of course much better capability to host your Postgres and MySQL database, which we are calling a flexible server. And key tenets of flexible server are gives you a maximum control to manage your database, almost like what you kind of control you have when you're running your Postgres or MySQL on a VM or on premise. And it has a much simplified developer experience, and it gives you capabilities like maintenance windows, zone resiliency, and things like that. And so we believe it's a very powerful combination on top of single server to host your Postgres and MySQL database. So we went into public preview with flexible server in September 22nd of 2020. And some of the questions that people have asked us is, why introduce a flexible server when single server is such a compelling offering? Why? Why is it flexible server? And this talk is to give you motivations behind that. Other questions come, is flexible server at feature parity with single server? Because if customer wants to deploy on flexible server, they want to know if it is at parity with single server, right? Makes sense. Or how's the workload performance on flexible server? What do I get in terms of performance? When are we GAing this service? Is it more expensive? Why should I deploy my workload on flexible server? All these kind of questions keep coming to us, and we want to address those questions in this conversation. And then finally, yes, I like flexible server, but I'm running on single server. How do I migrate my data from single server to flexible server, right? So before we go into deep into flexible server, it makes sense to take a pause and understand what single server actually is and what it offers to you. And then we will also look at some of the challenges that we have seen with customers, and then we will walk through how flexible server addresses those challenges, right? So if you look on the left side, a flexible server, sorry, in this case, single server is deployed in a region, which could be, US East, US West, India Central, India South. I mean, it's a region. So you deploy your Postgres service in a region. So this is Postgres here. It could be MySQL as well. And this Postgres engine is hosted in a container. Think of container as a sort of a self-contained secure boundary unit that is running inside a VM. And interestingly, we run multiple containers inside a single VM, right? So you can think of a single VM is holding multiple containers, and each of those containers is either running a Postgres single server, or it is running a MySQL single server, or for that matter, even MariaDB single server, right? That kind of infrastructure. And underneath, it is connecting to the network storage called general purpose storage, which is SSD based, and, uh, and that's how it is connected, and your data is accessed, right? Now, when you connect as a client, here I'm showing a client you are running on a VM inside Azure, but it doesn't have to be inside Azure, right? And you connect to your Postgres server through a gateway. So basically, what happens is your connection comes through a gateway. Gateway decides which server it goes to. It comes here, and then your database is running, right? This single server design, as I said, has been successful. It is exactly the same model where Azure is hosted with SQL DB, Azure SQL Server, same model. And it is built for high availability, elasticity in terms of scaling up and down, both compute and the storage. And it is very secure. I mean, it is running on a public cloud, Azure, which is the most secure public cloud in the world today. And also, Azure offers you a very rich ecosystem. And by running your Postgres or MySQL inside Azure Infra, you can easily sort of integrate with that ecosystem. For example, you can do BI, you can do Azure Active Directory for strong authentication, or you can do data ADF, Azure Data Factory to ingest data, and so on and so forth. So that is the design center for single server. The trade-offs that we have made for this design is out-of-box performance is not as robust as you would understand. It needs some tuning. And also, there is some difference with respect to the familiarity, and I'm going to talk about that. Okay. Now, some key facts about single server is it was GA'd in 2018, almost 2.5 years ago, and we have many significant workloads running on single server. For example, HSBC, which is on MySQL, and Adobe on Postgres. And we are seeing a significant year-over-year growth of Postgres and MySQL, owing to the fact, number one, Azure is a very compelling platform, and we are seeing many organizations are standardizing on open source technologies. We have added intelligent performance. We have a much closer integration with Azure Infra like App Service and Kubernetes. And we also are investing big time into single server technologies since it was GA. So some of the notable things that we have added is integration with Azure Active Directory. In terms of security, we introduced BYOK, bring your own key, for encryption, VNet, advanced threat protection. We have scaled the storage from 4 terabyte when it first came out. Now you can do databases up to 16 terabyte and 20,000 IOPS. We have read replicas, and we introduce logical encoding for moving data in a logical sense across multiple services. So you can imagine, right? This is a very robust platform running tier one workloads, and engineering continues to invest in making our customers successful, right? So all good. So the now we should look into what are the key challenges that we have seen with some of the customers, and to give you a sort of a base to build on to understand why flexible server could address those differences. Okay, So one of the key challenges that we have with single server, as I said, it is the higher latency. And higher latency comes for essentially two factors. Number one, the connection in direction through gateway. So all connections, as I showed in the previous slide, that connection is coming from a gateway, right? So there is a double hop. You come here, then it goes to Postgres, you run a query, query comes via gateway to Postgres and goes back, right? Same thing for MySQL. So that is the first latency issue. And the second thing is, at this time, there is no way you to control which availability zone your client, your database server, and the storage resides in. So if you look at three possible deployments that I'm showing you on the bottom left, and think of these data centers as like a availability zone. I'm saying in a very loose way, right? A availability zone can have multiple data centers, but think of in a very sort of a simplistic way, a data center is a synonymous to availability zone for this conversation. So, so if you deploy and it so happens that you get lucky and all your app tier, the gateway and the database and the storage gets deployed in the same data center or availability zone. That is the best combination for the lower latency. Because when you create this Postgres or MySQL server, you can only say region. Now, based on that, we can deploy these database in any availability zone based on the capacity, right? So now another possibility could be that your app tier is running in data center one, right? Availability zone one, and everything else is in availability zone 2, which simply means is that you are going across availability zone to reach to your database, and the latency within the data center or the availability zone is under 1 millisecond. And when you go across availability zone, it can be anywhere from 1 millisecond to 4 milliseconds, right? It depends on the region. So as it is, you are adding latency to the your client and database. And the worst case possible is that you have app in AZ1, gateway and database in data center or AZ2, and your storage is in AZ3. This could be, a much worse situation where even when database is accessing the storage, there could be higher latency, right? Now, interestingly, when you deploy, you don't know which deployment you got. And also, as you scale up and down your deployment, this configuration could change. I mean, you may, when you first deployed, you could be in deployment one, and then you start scaling up and down. It is quite possible that your database engine moved to a different availability zone, right? So you can see by scaling up and down, sometimes your latency could change, right? And that becomes a very surprising factor to many customers. So the key learning that we got from this experience, and as I said, this experience spans multiple years now, that we must eliminate gateway to reduce latency, number one. And second thing is we need to provide a option for customers to place their database, the storage in the same availability zone as the client. And so that's the learning we took forward for flexible server, and you will see how that is exposed. Second thing, which actually was many customers talked about, that the monthly maintenance. As you know, like any database and infrastructure, there are changes that happen on a regular basis, and those changes have to be deployed because this is a managed service, and we are responsible to deploy those changes. So we deploy every 30 days. Right? Now we obviously group the changes or the batch the changes to deploy every 30 days, right? We don't sort of deploy as soon as the change comes, right? We sort of batch them, and we follow the Azure safe deployment practice. All those things are being followed just like any other service in Azure, right? And we also give a notification up to 72 hours, right? We will tell you, hey, you will be sort of going through a maintenance, and there's a 72-hour notice, so you can plan your production workload. And these maintenance happens, off business hour, 5 p.m. to starting from 5 p.m. and the next morning 8 a.m. Now, one can argue, well, these days of a 24/7 culture, there's not really a off hours, right? So, but that's the window we have. And but that's a window of maintenance. Does not mean your system is down for 15 hours. It's just that during that window, some point in time, you will deploy the change. And when the change is deployed, you're down for a couple of minutes, typically. From that perspective, it's not a big deal. But I think many customers are concerned about, well, this is a 15-hour window. I'm running a long batch job, or I'm creating an index. I don't want it to fail halfway through, right? Because then I have to repeat the process. So that is one of the challenges customers have been telling us, and it makes sense, right? But having said that, all the 72-hour notification once a month, but if there is this critical security vulnerability, we will, of course, reserve the right to deploy the change, right? So, challenge customers have said is they want to align uh, their maintenance window with their convenience rather than something from an Azure perspective, right? So, they want the control. Now, to improve the process of maintenance on single server, we have done the changes. As I said, we have been investing. So, for example, we have reduced the the process of maintenance window from 15 hours to 10 hours in public rings. I mean, that's like 30% reduction, which is good. And for some customers, we are offering premium rings, which you can further reduce your maintenance window to 4 hours. So imagine for 15 hours, you went to 4 hours. But even then, many customers are not satisfied. They want a much finer control. So the key learning for us is that provide customers a window they can control for their maintenance, right? Now, the third challenge that we have seen is with connections. And this is actually very significant, and I want to talk through that. The first challenge is that connection requires a append of server name to which you're connecting as part of your username. Now, this is a non-standard change. So if a customer was running Postgres say on premise or on a VM and they have a connection string, but now when they come to Azure uh, PaaS, they need to change the connection string to include server name. And for many customers, this is non-intuitive and they run into problems, right? So it's something we have heard many times. Remove the requirement for add server name from the username. Second thing is the establishing a connection is a lot more expensive on PaaS with Postgres and MySQL. And the implication is if a customer was running a workload on a virtual machine where let's say establishing the connection is like 20 to 30 milliseconds on Azure PaaS for Postgres, for example, it takes anywhere from 200 to 300 milliseconds, right? 10 times longer. And suddenly, if they had a application which creates a connection, runs the query, closes the connection, if you have a lot of these short connections, suddenly this 2 to 300 millisecond is added on top of your query, right? So suddenly the system looks very slow, right? So that I think is a big challenge for us. And then finally, there's a hard limit on the number of connections that you can have within a given SKU. Now, this we actually came up with these limits using a very complex set of memory computation so that we can provide the SLA that we can stand behind. We offer 4 nines of SLA. So because as you can imagine, right, each connection takes up to 2 megabytes of physical memory, right? So if you allow a lot more connections, suddenly your memory available to your workload is reduced, things like that, right? And Postgres engine, for example, does not offer very sort of a resilient way to handle out of memory situation. Sometimes it crashes, right? So we have to be very careful. So just that. Now, these problems are there on single server, and we have provided many best practices to address these things. Right, one of the best practices that we have is to use connection pooling. So many applications, which I would say establishing a connection pooling is a much better technique because even if you have short time to connect the connection, but why even spend 20 milliseconds creating the connection when you can pool it? So you can we recommend you to do connection pooling, and you can do connection pooling using a PG bouncer, or you can also use PG bouncer sidecar for Kubernetes, right? So we offer those capabilities. And also uh, in a cloud world, because it's a very complex infrastructure, sometimes you will find the latencies are there, so you need to sort of uh, uh, look at your application so that If the number of connections are increasing, it can back off, or you have retry logic and things like that. So some changes are needed in the application to run, not every time, not every case, but yeah, to make it more resilient. So these are the recommendations. And customers say, I don't want to make changes. Customers have made changes, but they're not happy about that, right? In many cases, the application is not even in their control. So the key learning that we got from that one is remove the requirement of add username from the user ID, reduce the time to establish a new connection, decouple the connections, max connections on a SKU, right? I should be able to change my number of connections independent of the SKU I'm running, right? And then integrate this PG bouncer or connection pooler inside the server. So I don't have to worry about changing my client. I just, enable connection pooling inside the Postgres service, for example, and I can connect to it. Now, the last thing that I want to talk about is the AZ Resilient HA. Now, what that is. Now, if you look at a single server, again, for both MySQL and Postgres, it provides you resiliency out of the box with compute failure, with the storage failure. However, it does not provide you resiliency with the AZ failure. If AZ goes down, like I said, when you deploy your Postgres or MySQL, you have no control where the database tier is in which AZ, right? Or where your data is, right? If the AZ goes down, let's say it happens to be the data tier where that AZ went down, your database becomes unavailable, right? So the recommendation we have for those customers is either have a read replica in a different geo or have a GeoDR situation. But in both situations, there is a interruption to the application, and many customers are saying that is not acceptable or they are not happy about that. Now, granted, the availability zone going down is a rare phenomena, but many tier one workloads want that guarantee and willing to pay for that, right? So lack of easy resiliency is a big issue for some of our top customers, right? Okay. So now if you look at how availability works in single server today, so for example, you have this server that is running inside a secure container and you have a gateway, right? And the connection can come from a MySQL or a Postgres application. So let's say server goes down, we immediately create a new server, right? And then it connects to the storage underneath. So for you, it is like as soon as we detect the failure, we provision the new server for you, and the data gets connected because data is still there, right? So you may expect or you may experience a minute or two of downtime, but sometimes you may experience longer downtime if you had a long running transaction, a very high transactional activity, because when you provision a new server and do the recovery, it can take time depending on the workload, right? Similarly, the storage goes down. Like here, I show the three copies of the storage, three synchronous copies of the storage, right? If one storage got corrupt, maybe bit flip happened, or it actually went down, right? You still have two storage, and life is good. And behind the scene, we will create a new healthy storage, make the copy, and you'll be up and going, right? So that's the scenario we have in the background. So the learning for us is, sorry, I forgot about that. Learning is that we must provide a easy, resilient HA with automatic failover and no data loss. Now let me do a demo for you guys, and I think it'll be useful to see that what happens with the provisioning today. So what I'm going to do is I'm going to go and I'm going to go to Azure portal.ha, right? Portal azure.com, and I'm going to create a Postgres service. I want to show you something on this one. And so this is my portal, and I'm going to say create a new resource, right? And I'm going to say Azure database for Postgres, right? Let me click on that. So here I'm going to say create one, and notice you will see multiple options. So for example, I'm showing you single server option, hyperscale Citus, Arc option, and the flexible server option, the one that I was showing you. So let me do a create here on a single server. When I come a create here, notice when I say I give the server name and whatever not, but the location that I give is a region. I have no way of saying within that region which AZ I need to create my Postgres server. So we don't have that capability. So that is one thing I wanted to show you. Now, the second thing I want to show you is once this server has been created, now this is my single server Postgres that I've created, you will notice that my connection string requires a add Sunil -pgs2, which is my server name, right? Or you can even click on connection strings settings, right? And you will notice that, hey, I need to specify this connection string, right? That I think is a point of pain for some of the customers, and they want us to change that. Second thing I want to show you the connections, right? If I go to server parameters, right? If I go to server parameters and I want to show you what can I do with the connection, you notice I don't have any way to control how many connections I need to configure for my server. As I said, many customers have asked us to fix that problem, right? And that option is not available. And if I go to the limits, right? This is the limit that we have, for example, on Postgres. So depending on what SKU you have created, the max of connections are sort of fixed. If you want more connections for your application, you need to go to a higher tier, even though, for example, if I wanted 600 connections, I have to go to general purpose 16 vCore machine, even though I may not need 16 vCore computing power. So these are some of the challenges that we have seen with our customers. And as you know, that flexible server is designed to address that. So let me go back to the presentation here. So with flexible server, what we have done is we have improved the latency significantly by eliminating the gateway and providing you an option for co-location. It provides a much better out-of-the-box performance. You don't need to tune it. You just deploy your database on flexible server. You get much better performance. We give you a full control on when the maintenance will be done. Uh, we obviously provide AZ resiliency in the sense you can choose when you provision it, you can have a standby, the hot standby on a different AZ. What it means is when your primary goes down, we automatically fail over to the standby and your application can connect to the standby using the same connection string with no data loss. We improved the telemetry accuracy. We allow up to configuring up to 5,000 connections, and that is not dependent on the SKU. There is, of course, a safe limit, but we allow you to exceed that if you test your application to make sure that the remaining memory works for your application. And we have done a significant investment in improving the developer experience. So for example, we have removed the add server name from the connection string, right? We provide much better defaults when you're provisioning, and Parikshit will show that. And we also provide a start-stop capability because if you're a developer, you're not developing 24 hours a day. You're working, say, 10, 12 hours. Once you're done, you want to stop the server, right? So that you don't pay for it. Next morning when you come, you start again and life goes on. We provide a much lower SKUs, personal SKUs. You can scale up and down as before. PG Bouncer has been integrated inside the server, and we have a much better guided experience to integrate your application with app service and AKS. So that's in a nutshell why uh, we introduce a flexible server to address some of the challenges that we have seen with single server. Having said that, many customers are very happy with single server, right? But those customers who need those capabilities I was talking about, a flexible server is a choice. Now I'll give it to Parikshit, who will walk you through the details of the flexible server. Thank you.
Thanks, Sunil. Hi, everyone. Welcome to Data Platform Summit 2020. My name is Parikshit Savjani, and I lead the program management for Azure Database for MySQL and MariaDB service. Sunil shared with us some of the learnings which we have had in our single server deployment offering for Azure Database for MySQL and Postgres service. In this section, I will take you through our flexible server architecture, our features and capabilities which flexible server provides, and how it allows us to overcome some of the limitations which we had with our single server offering. Each Azure region consists of 1 to 3 availability zones. When you provision a flexible server is actually provisioned in a given or specified availability zones. When you provision a flexible server, a Linux VM is deployed or provisioned, and MySQL and PostgreSQL is further deployed on that VM and configured, right? This is the first important and major difference between our single server and flexible server architecture. In case of our single server architecture, the database engine is packaged in a container, and container forms the tenant boundary. Whereas in case of flexible server, each tenant gets the VM, or in other words, VM is the tenant boundary. This allows us to provide more control and flexibility to the customers, which we are going to talk about that later in this section. Now, storage and compute is separated, and the storage is replicated 3 times within a given region or a data center. This helps us provide high data redundancy, and thereby enables us to provide data durability in the service. In case of Postgres, storage is Azure Managed Disk. In case of MySQL, storage is Azure Premium File Storage. And the VM and storage together forms a flexible server architecture. As you can see, compared to our single server architecture, there is no gateway in this architecture. And this first cut down one layer of latency, which you would have seen in case of our single server architecture, whereas in case of flexible server, there is no gateway involved. So that helps improve your latency right out of the box. In addition, whether you're running your application on Azure Kubernetes services or VMs or VM scale sets or app services, you could co-locate your database tier in the same availability zone as your app tier. This further helps cut down cross-zone database latency. So this is a second layer of latency which you could cut down with flexible server by provisioning your flexible server in the right availability zone, co-locating it with your application tier, right? Further, backup storage. So the flexible servers, for flexible server, we take backups by default. The backup itself are replicated into 3 replicas. This provides highest level of data protection. And similar to single server offering, with flexible server also we provide locally redundant storage and zone redundant storage. In case of Postgres, the database backups are taken in zone redundant storage by default in the regions which support zone redundancy. For MySQL, the backups are stored in zone redundant storage when you opt in for zone redundant high availability. This allows you to restore your backup across the zone if you have to, in case if a zone is no longer available or it goes down. So this provides you with the highest level of data protection, which was not available in single server service, right? As you saw in the previous slides for flexible server architecture, we have significantly cut down your connection latency by eliminating the gateway, and further you could co-locate your application and databases resources together, which allows you to cut down the latency further by avoiding cross-zone latency, which is there when your application and database are in separate zones or separate data center. We perform benchmark testing comparing flexible server and single server using sysbench and pcbench, and here are the results which you see. With flexible server, you could expect around 80% reduction in connection latency and 70% reduction in query latency. And further, that translates into higher throughput too. With flexible server, you could expect around 200 to 300% boost in your transactions per second. Finally, here is some of the early adopter feedback from the customers who were part of this journey while we were building flexible server offering. These customers performed their workload testing on single server and then redid the same test with flexible server, and they compared the difference, and here are the codes in their own words. Flexible server is not just about performance. it's also about improved developer experience for our first-time users who are new to Azure or new to our service. We have significantly improved our provisioning experience in Azure portal. To simplify the experience for first-time users, we've added something called as easy create option with smart default that allows or that chooses the right SKU based on the workload type which you want to provision the server for. For example, if you're provisioning a server for development needs, we automatically choose burstable SKU with no zone redundant high availability because that doubles the cost. So the choice is optimized for cost. Similarly, if you choose to run a production kind of a workload, the SKU which is chosen is optimized for performance and high availability. Further, we have simplified our CLI experience and reduced the number of steps for a developer to provision a flexible server. In case of a single server, if you're using CLI, you will first have to provision a single server offering, and then as a second step in the CLI, you would add the firewall rules for your clients to be able to connect to your server. In flexible server, all of this can be done with the single command. In the same single CLI command, you could provision a server, you can configure the network isolation and zone redundancy as well. And further, for development needs, if you are looking for a quick and a dirty server where you don't care about the server name, it's a throwaway server, all you have to do is fire a single command called Azure MySQL Flexible Server create and specify the Azure region where you want to create that server. This command will create the server for you with a system generated name and the system generated password in a system generated resource group. And the output of the CLI command will give you all those details which you could quickly use and connect to the server and get started with the development. Finally, native connection experience. Yes, I mean was the most common feedback from a lot of our customers where they want a native connection experience where their existing application just works. So as you could see in the connection string, there is no username at the connection at server name in the connection string, which you would see in case of single server offering. Here it is seamless, and you could expect it just works. Your existing application would just work. With flexible server, we have introduced low-cost burstable SKU, which is very useful for development needs. With burstable SKU, you get initial credits when you have just deployed or provisioned a server. And as long as you're consuming less than the baseline CPU, you continue to accumulate those credits. Those credits can then be used for you to consume more than or exceed the baseline CPU for some time in a given day. If your credits are exhausted, in that case, you can still continue to consume up to your baseline CPU. Your credits are only valid till 24 hours. At the end of the 24 hours, the credit gets reset. So if you think about burstable SKU, it is very useful to you for development needs. When you're writing the code, your CPU consumption is generally much lower, and when you're performing testing of the code, that is where you start to consume more CPU resources in a given day. So it is very useful for development needs. It's highly recommended for development needs. In addition, if you have some of the WordPress blog sites which has only few hits in a day, or if it's an app which is used for swiping the card, which only has an active period during certain times of the day, burstable SKUs can be very useful for those kind of scenarios. And further, to save cost, you could stop the server at any given point in time. So you could stop the server, and the compute cost you will not be billed for the compute and only storage is charged. Now, if you look at your total bill, cost is generally less than 10% of your total bill. So you can expect around, like, if you think about 30 burstable SKU, which is available at $13 per month, $12 is the charge for compute and $1 is storage. So if you shut down the compute, your storage cost, you only end up paying $1, and it gives you significant boost in your productivity because you don't have to delete the server every time. You don't have to restore the database every time. You just have to shut down the compute, and when you're ready to work on it, you can start the compute again and start connecting and start developing or testing. Next, let us see some of the things which we have discussed earlier in the slides in action in this demo. So here, let's start with a CLI mode for deploying or provisioning a flexible server. The first step for us is to set the subscription to which you want to deploy your flexible server. So that is what I'm doing here. This is only required if you have if your account is mapped to multiple subscription. The next step is for us to create a resource group. Resource group is a logical container in Azure where you could put in all your Azure resources together. The next step for me is to identify my client IP address. This is required because I want to create a MySQL server with public access enabled, and I need to know my client IP address with which, so I can open the firewall ports for that IP. Next, we create the single Azure MySQL flexible server with the single command we discussed earlier. And the output of that command is also provides me with the connection string as you see on the screen. So I use that connection string, connect to my MySQL server using the MySQL client, fire some queries like select version to show me the version, and also fire show databases. It also creates one user database called flexible server DB in addition to the system databases. Now, when I'm not using the server, I could use Azure MySQL flexible server stop and the name of the server to stop the server. Once the server is stopped, if I try to connect it, I get an error, as you could see. Next, when I want to start working on the server again, I would create Azure MySQL flexible server start. The server is started. I'll again try to connect to the server and see if I'm able to connect. Yes, I am. And I'll quickly fire the same queries to see if my database persists, which is there. And once I'm done with my development or my testing, I could go ahead and delete the server, AZ MySQL flexible server delete. And once, if you no longer need the entire resource group, you could create and delete the resource group too. So here's a quick CLI demo about like provisioning an Azure MySQL flexible server using CLI, or connecting to the server as well using MySQL client, CLI client, stopping the server, starting the server again, and once you're done, you could delete the server and kind of destroy the or delete the resource group as well. Next, let's see how flexible server allows you to have maximum control of your server. As your managed service provider, we periodically patch your servers in order to provide the new features and capabilities and to ensure your server is secure and up to date. The patch would contain software updates like the database engine upgrades, OS upgrades, service agent upgrades, and even hardware and infrastructure update. With flexible server now, you could control the planned maintenance window during which you want the patch to be rolled out on your server. You could configure custom schedule per server for each of your servers, and you could choose a separate schedule based on your environment and needs. When the patch is rolled out, or when the patch is ready to be rolled out, you will see a 5 days advance notification that the patch is now ready to be rolled out at your specified day of the week and the time window. You would specify 1 hour time window compared to 15 hours of time window which is there in single server, because we used to patch the entire region at the same time, and here it is your 1 hour window during which your server will be patched. When the server is being patched, during that time you can expect around 60 seconds of downtime, which is generally like a failover event to the hot standby when the servers are being patched for your environment. And once the patch is completed, the next patch is only available after 30 days of time, so you have sufficient cooling period. You are not bombarded with frequent patching. So here's how you could control your maintenance window with flexible servers. Next, with flexible server, you could control your network isolation configuration settings and discoverability of your database server. You could configure your server in public access mode where it is discoverable out in the internet, but you could control the access to the server by through firewall settings by defining a client access list. So only the restricted client IP addresses which you specify in that access list can connect to the server while it is discoverable out in the internet. You could alternatively, you could configure your server in a private access mode where only the clients which are present in the same virtual network or VNet in Azure are able to discover your server, and further they are able to connect your server. In both the isolation mode, which is public isolation mode or private isolation mode, SSL is turned on by default with TLS 1.2 encryption by default, which is the highest level of encryption we have, and which is supported by the database engine. And the encryption cannot be turned off, so which means your data is always encrypted at rest as well as in motion all the time. Server parameters are way for you to control your database level configurations and settings. It is similar to what you do or when you configure your own Postgres or MySQL server and you have access to postgres.conf file or my.conf file, where you configure the server and some of the collation and other settings when you start the server. You could do the same things with server parameter. With flexible server architecture, which I shared with you earlier, with tenant VM boundary, we can be more lenient compared to our single server offerings, and as a result of that, we've opened more server parameters than what is available today on single server offering. And with this new architecture, we can afford to be more lenient, and you will see there are more server parameter controls available with flexible server, which I'm also going to show you in the demo later. As we saw earlier in the architecture for flexible server is zone aware. In other words, when you configure or provision a flexible server, you would specify an availability zone, and generally you would co-locate your flexible server in the same zone as your application tier as well. When you turn on zone redundant high availability, which is a feature available at the time of server provisioning, another flexible server gets created on another availability zone with the same SKU and configuration as your primary server. This new flexible server acts as a hot standby of your primary server, and the data from the primary server is continuously and synchronously replicated on your standby server. This architecture allows us to provide high data resiliency with multiple synchronous copy of the data available across availability zones at all the times. In the event of an outage of any of the dependent service, or if the entire zone goes down, the services or the database is automatically failed over, and your database comes online on the standby availability zone. Now, for the high availability or for the entire application stack, we would also recommend you to provision our application layer as well across multiple availability zone. So with zone redundant high availability, you can have zero data loss, or you will have zero data loss, as every transaction which is committed on your primary server is synchronously replicated and acknowledged only once it's committed on the standby server too, right? Further, with zone redundant high availability feature, it also helps you cut down your downtime for planned maintenance, as when your servers are upgraded, your standby server is upgraded first, and your databases are then failed over, so your downtime is cut down, and your downtime is generally less than somewhere around 30 to 60 seconds. So with zone redundant high availability, you can get highest level of availability and resiliency in the Azure infrastructure, and we would highly recommend this for any mission critical databases which you configure for your environment. With that, let us jump into the demo to see some of the things we discussed earlier, the max control and the zone resiliency feature with flexible server in this demo, and see them in action. So here we create a new flexible server using portal experience, which I discussed earlier. Here we are creating an Azure database for Postgres SQL instance. There are 4 deployment options as Sunil discussed earlier. We are looking into flexible server here. Here I provide the resource group, which is a logical container under which the database resource is deployed. I provide a server name which is unique, not just unique to me or my environment or my subscription. It should be unique DNS name, which is not taken up globally. You specify the region in which you want to create, and you specify the easy create option. So I go with the production option. So in East US, there are 3 availability zones. So I pick the availability zone 1. And here, this is the high availability zone option. So it is available at the create time. So you check in to ensure that you want zone redundant high availability. Then you specify the version, your admin account for the server. provide the password as well. And next, once you're good, you can click on review create. But if you have not specified your network isolation, and by default it's public access, and you forgot to provide the IP address, you will not be able to connect. So it reminds you, and here it reminds me, okay, let me configure private access and specify a virtual network which I have created earlier, and a subnet, and the subnet should have the delegation permissions for this resource called Azure Database for MySQL for Postgres. Then I will click on create for the server to be created. It will start the deployment. Generally, the deployment for standby with server with zone redundant HA is longer. You could expect somewhere around 15 to 20 minutes of the time. Here, I have kind of edited this demo so that we don't have to wait for entire 20 minutes. So once the server is provisioned, the next what you will do is let's go into the high availability tab. This is checked on, and you cannot uncheck it at this point in time. But you would see this is checked on. It shows you what is the status of availability, your primary availability zone, like which server is primary and which is the standby server, or where the standby flexible server is hosted at this point in time. So you could see that. Next, plant maintenance, the control, whether you want to go with system schedule or custom schedule. So here I'm choosing, like Sunday night is generally preferred by many customers, as we have seen. And here the time window is in UTC. It's not your local time, so just be mindful of that and specify a 1 hour time window which works best for your environment, and save it. In my case, I've specified this as 2 a.m. UTC. Next, we look into server parameters. So when you looked at the demo shared by Sunil, there was no option for you to configure max connections. With flexible server, now you can configure a max connection, and you can even exceed the max connections if there is memory available on your server. So here, if you see, my max connection was 859 for my SKU, but I have gone ahead and increased it to 2000. Because I might need more max connections, so you don't necessarily have to upgrade this queue. You will try and increase the max connection. First, if there is memory available on the server, you could use it, and this is possible because we have the VM tenant boundary, and we can give you more control through server parameters. To take that effect, I have restarted the server here, and now after the restart is completed, let's go ahead and check the connections again to see if the value is persisted. And as you see here, the max connection value is, you could exceed than what is configured and available to you as default. Now here is the key summary or the key takeaway from whatever we have discussed so far, and this is what I want you all to kind of take out from this particular session. With flexible server, you have maximum control on your databases. You can control your plant maintenance window, you could control your server parameter configuration, and you could also control your network isolation settings. With flexible server, you could build zone resilient applications, which provides you highest level of resiliency and availability, which is possible in Azure infrastructure. And further, you could co-locate your database server and your application tier together in the availability zone, cutting down your application latency. And finally, with flexible server, you can expect a simplified development experience, easy provisioning experience, whether it's portal or CLI, and you have cost optimization controls for your development needs with burstable SKU and further start-stop features. Now, your dilemma would be, when should I use single server versus when should I use flexible server? So here is a quick summary and a recap of the things to guide you and to help you make the right decision for your new development or deployment offering. With single server, we also support some of the lower versions for MySQL and Postgres server, whereas flexible server, you would only see we supporting the latest version of the offering. So if your application has dependency on lower versions, you might want to choose with single server, whereas for the latest versions, you might want to start with flexible server offering. High availability. So as you saw, like with flexible server, we provide zone resiliency and zone redundant high availability feature, which is exclusive to flexible server only. So if your Azure region supports your preferred Azure region supports zone redundant HA, and if that is critical for your application, you might want to go with or start with flexible server. Now, it is also important for you to know and understand some of the Azure regions today do not have multiple availability zone. They might have only one availability zone. In that scenario, zone redundant high availability feature may not be available with flexible server. In that case, the availability of single server and flexible server is very similar. So you can make a decision, or in that case, the availability options doesn't matter, but Azure is further adding new availability zones in all the regions. So you will see as the new regions have availability zones lighted up, we will also start supporting zone redundant high availability feature with flexible server on those regions. Schedule maintenance, if you don't care much about the plant maintenance window, then you can choose single server. But if you want to specify a custom maintenance window, a 1 hour deployment, and you can schedule it, then you might want to choose flexible server offering. Start stop, Postgres doesn't support start stop feature on single server. So if you're very interested to use start stop feature for your development needs, you might want to start with flexible server. For MySQL, start stop is supported in both single server and flexible server offering. Backup and restore functionalities are exactly same in both the services. So these are exactly same. You can have the same point in time restore functionality. The backups are captured with the same frequency. The only difference being the backups can be are performed on zone redundant storage in case of flexible server offering, whereas in case of single server offering, it is only on local redundant storage. Network isolation is pretty much same. The only thing is the private isolation is supported through private link in case of single server, whereas in case of flexible server, it is supported through VNet integration. Next, customer managed keys. So data encryption is on by default for both single server and flexible server offering. But if you're looking to encrypt your data with customer managed key, bring your own key, that's currently only a feature supported in single server, but it's planned for flexible server. We'll be adding that very soon. Reserved instance again is only supported in single server offering. And cross-region read replicas. If you want to create a geo read replica across a different Azure region, that is available only in single server today. It's not available in flexible server, but it is definitely planned, and it's there in our roadmap, and we'll add it soon in the coming upcoming releases. SLAs, since flexible server service is right now in preview, there are no SLAs. So we don't recommend you to run your production workload right now on flexible server offering. If you are thinking about your production deployment, you should definitely start with single server at this point in time, which provides 4 nines of SLAs. So in summary, here is a quick snapshot for you to know and understand when do you want to use, or when should you use single server compared to when should you use flexible server. Next, let's talk about some of the frequently asked questions which might have come to your mind and which we anticipate, which we have seen a lot from our customers and users after listening and learning about flexible server. When will flexible server be GA? Our roadmap and current plan is to GA flexible server sometime in H1 of calendar year 21. So we don't have specific timeline yet, but to give you a ballpark, it is first semester of calendar year 21. The next question is flexible server available at the same cost as single server? Yes, flexible server is priced at the same price as single server for the same vCores and storage. In fact, there are low cost SKUs available with flexible server, as you saw Burstable, which is starting at $13 per month. In addition, if you opt in for zone redundant high availability, then your cost will be double, as there is a parallel server which is running as a hot standby. Is flexible server available in all Azure regions today? Answer to that is no. Flexible server is available in around 10 to 12 Azure regions today, but we are adding new regions every month. So you would see flexible server eventually come into your preferred Azure region if it's not there already yet. But if you compare single server with flexible server is available in many Azure regions today, whereas flexible server currently is available only in 10 to 12 Azure regions. How will I migrate from single server to flexible server? Currently, your option for to migrate from single server to flexible server is using logical dump and restore. In case of MySQL, it's MySQL dump and restore, whereas in case of Postgres, it's PG dump and restore. Alternatively, if you want to automate this, you could use data migration service. Data migration service will support migrations from single server into flexible server soon. So that is planned, and we will make that experience much simpler and easier. But at this, as it stands today, logical backup and restore is your option. Where can I learn more information and news about flexible server? So that's a good segue for my next slides. First is our documentation. So you could go to our flexible server documentation to learn what are the features which are rolled out, and understand in detail about all of these features and functionalities which I talked about in this session. Next, we have a tech community blog where you could learn more, and you could subscribe to this blog as we add new features and releases. We will continue to add more blogs, so you will get notified when a new feature is get added. So we highly recommend you to subscribe to our blog. If you are looking for some customer references, that who are the customers who are running today on our Azure database for MySQL or Postgres service, then you can look at the customer stories which are there. And finally, if you have any questions for us, which is not covered in our documentation or in the blog, you can email it to us. There is a separate email alias for Azure database for MySQL and separate for Azure database for Postgres. Next, what are the other open source database sessions available in Data Platform Summit? Here are the list of the sessions. For migrations, I would highly recommend you to get into the session from Arun and Sunil. It talks about best practices for migrations from on-premises or from other cloud providers to Azure. Next, Sunita talks about cloud native app development with open source databases on Azure. Next, we have Amol talking about your performance and tuning with MySQL engine, and how you can tune your MySQL engine to make it fast, resilient, and scalable. And then if you want to learn more about our new offering, which is a hybrid offering, which is Azure Arc enabled Postgres hyperscale, then you can get into this session from JY. So finally, thank you all for taking the time out to listen in and to attend our session. I want to thank you in whichever part of the world you are. So yeah, let us know if you have any questions.